stuff. I didn't want to put a lot of the components on the board itself right now because I figure we'll still grab this thing. So I'm using basically breakout boards and making the breakout boards fit without trying to, because every little bit I could make it shorter was a fair bit less money to Osh Park. And so, you know, the physical spacing was actually more of an issue than probably most of the boards I had done before. But this kind of gives you an idea of what it looks like. The Pro Mini, the real-time clock, which I just use a DS1307 straight up. This is a high-side current voltage sensor that can go up to 26 volts from Adafruit. And then I used an OLED display because I could get just more data on it in a small footprint. And the it actually works pretty darn well. So let me give you a quick demonstration of it. There's two pieces to this. One is the on the Arduino itself. The program actually brings up a display that gives you a kind of an interface to control the device. And now I'm going to see if I can split this.
You rock.
Oh. So now what you can do is you can actually control the device. And so you see right now the load is off, the source is off. It's telling you the time, which isn't that big a deal now. But you know, when I do want to get this thing, let's say to do a rundown test of the battery, logging the date and time is actually kind of important, so we know how long the battery lasted, when it died, and things like that. I can turn on and off these things. So, for example, if I turn on the source, what you'll see is now the voltage. I'm using a LiPo single cell battery, so it comes up and says, "Hey, I see 4 volts." As you can see, that P MOSFET is a pretty good switch. It's not a perfect switch, but it's a pretty good switch. So I'm getting a little bit of current through there, but it's basically turning this thing off, and then I can set the duty cycle. So what I wanted to do is...
What's the purpose of the resistor there?
Yeah, thanks. So the load in this case, so I could have used like Pete's constant current load. I could have put that on for the load, but I just put a nice beefy resistor, because the thing that I can do now is I can kind of determine how much of that it's going to see based on the pulse width modulation. So that NFET that's switching the load, that is, I'm pulsing that 900 times a second. I think if I remember right, pin 6 on the Arduino, the pulse width modulation is about 900 hertz, if I remember right. Something like that. So what I can do is I can set a duty cycle. So let's set the duty cycle of 50%. And now what it's essentially like taking that resistor and doubling the resistance in the sense that the Arduino, instead of a 10 ohm resistor, it's going to look like a 20 ohm resistor to it. So when I connect the load, what you'll see is the current ramps up, and you end up with current that's more or less equivalent to what you would see if it was a 20 ohm resistor. So it's kind of cool because now I can tell, I can put a profile in there. For example, on my power supply for my GPRS-based sensors, when the GPRS radio turns on and it's transmitting data, it's actually drawing a fair bit of current, almost 200 milliamps. When the GPRS radio turns off, it's just the Arduino, it's about 30, and when the Arduino goes to sleep, it's like 5. So what I can do is I can use pulse width modulation to kind of simulate those different modes and come up with a mix of loads that's probably closer to what the Arduino is going to actually see. One of the things that's kind of cool too is I'm using the analog pin to measure the temperature of the power converter. So I built a little DC to DC buck boost converter. Kind of hard to see, but there's a thermocouple, a TMP36 device glued to the top of that chip, so that as this thing runs, it can measure the temperature, and if the chip starts heating up too much, then I can cause the thing to stop. So I'm going to turn it off, and then I'm going to execute a test. And the idea here is I can program different profiles. So in this case, it's going to increment the duty cycle 1% every second. And what I could do here is I could say, hey, increment the duty cycle 1% each second until either the temperature goes too high or it fails to maintain the voltage that it's promising to that device that's on the load. And if either of those two things happen, stop and write the log file, basically, that I can then look at later.
Where does the log file go?
Yes.
The SD card or the serial or?
Great question. So I run this two different ways. Notice on the bottom left I put a button. And the reason I did that is I actually only have this one laptop and I don't want it tied up, days on end doing one of these rundown tests. So SparkFun has this really cool thing called the Open Log. It's a very cool little device. Basically it's about the size of a micro SD socket. On the top it's got an Mega 328, and on the bottom it's got a micro SD socket. And it plugs right onto the FTDI header. And to your Arduino, it looks just like your serial terminal. So what I can do is when it's doing the test, it can just output the logs as if I'm reading it in the serial terminal, or if I want to run it in disconnected mode, I can just put the open log on the FTDI header and just push the button to start the test. And then it will just run without the computer. And you see in the bottom right, I put a header for an external power supply. So with an external power supply and an open log on the FTDI header, it can run without the computer, which is what you saw in that one picture before on the previous version of the board. Works really well. Nice thing is you don't have to change the code at all. It just looks like a serial terminal. So
I think we should. I think that's it. Wrap up.
Yeah. So lessons learned. The collaboration thing has been fantastic, and obviously highly recommended. One of the things that Shane's talked about is this art and science of this stuff. There's like questions about what sizes of resistors do you use, or which BJT to make it a balanced kind of approach. Some of that is art, and some of that's a science, and we're going to probably play with it, but it's something that I think when you deal with somebody that's got a lot of experience with it, it's been very helpful. And then conventions are good. When I first started doing this, I had my own way of doing things, but by having certain conventions, like the ground points down, the load points up, all the pins are always the same orientation across the board, things like that, makes it a lot easier to work with other people. So I'll just leave it at that since we're out of time. And I'm documenting the project on Hackster. So if you go to hackster.io, you can go to hackster.io/CHIPMC, and you'll see all the projects that I put up there. This one's called Arduino Control Center. And as we get better at this and go into version 4 and version 5 or whatever, all the updates will be there. And any questions?
I noticed you have solder mask covering that pore on the top. I heard talk that if you don't put a solder mask on there and just tin the whole thing with a bunch of solder, you can reduce the resistance and increase current handling. Have you thought about doing that?
You mean like where I see, let's say like red here, if instead of putting the solder mask, it was bare copper and I tinned it with flux and some solder?
Yeah.
Shane? Yes.
Yes, you could do that. Not always recommended. The other thing about the solder mask is if you think you're at the limits, if you just leave off the solder mask, you actually get better thermal dissipation because the solder mask just acts as insulation. But you could leave it off. The thing that actually works better than that is if you can look at your actual shortest possible high current traces. If you leave the solder mask off and you have the template on, you can actually lay a 12-gauge solid copper wire over it and tack solder on and actually get much better conductivity than just slathering the solder on.
Yeah.
Plus you could create a little rectangle of no solder mask and still have solder mask on the borders. So you can solder 12 gauge wire on.
Yes, and leave a little moat to keep from
Crowding
encroaching.
and getting bridges and, you know.
Yeah, it's actually something I'm gonna probably look at with, maybe if
Right,
not this
dropping
more
the
than
screws.
next, but that idea of being leaving off the solder mask for, I thought of it in terms of better heat, but, you know, maybe you can lay more wire on top too. It's a good point, yes.
Do you high pot some of this, to, you know, with traces that are close to each other? High pot testing, which is high voltage testing?
No, it's called OSH trust.
Yeah, you mean, do I check to see if that gap is big enough to insulate between those two?
No, that there's no stray little hairs of copper in
No,
there.
I think that was the right question. It was a breakdown question, not a flaw.
Okay.
What,
Generally, high pot means that you apply high voltage to it to see that it
Yeah,
doesn't
high pot,
arc.
that's
That
what
it
high
meets
pot is.
safety requirements for
Oh, I see.
isolation.
I haven't gotten to that point yet, I mean,
Yeah,
it sounds like
you also
something.
use high pot to test faults. Well, stray wire.
Right. Any
I've
other,
never seen high pot
Of
use
course, then there's
functional electric
high
test.
pot plus high current, and that just eliminates the shorts.
We ran high pot.
That would take care of it.
Stuff all the time.
Church.
Well, it's for
All right.
different purpose.
I'm gonna just out of respect of time, I just want to, I'll move on.
It's all functional.
But thank you all for your time.
Thank you.